Welcome to The Explainer. So today, we're diving into one of the biggest challenges in AI. How do you teach a superintelligent system something new? Or, how do you correct it when it gets something wrong? Turns out, the answer is way more complicated and honestly, way more fascinating than you might think.
Okay, let's just jump right in. Picture an AI's brain. It's been trained, it's full of facts. But what happens when one of those facts goes out of date? Well, you get this problem right here. The AI might cling to the old, wrong information. That's the red X. When what we really need is for it to learn the new, correct fact, the green check mark. And this isn't some theoretical issue. It is a massive, real-world headache for today's large language models.
So this brings up the obvious question, right? The one right here on the screen. If these things are so smart, why can't we just tell it the new fact? I mean, it seems so simple, but correcting an AI's deeply embedded knowledge is shockingly difficult. And that question, that gets right to the heart of what we're going to unpack today. To really understand why, we've first got to wrap our heads around the AI's knowledge problem. Let's take a look at why updating these huge digital brains isn't anything like, say, editing a Word doc.
Here's the most crucial point. An LLM isn't a spreadsheet. It's not a database where every fact lives in a nice, neat little cell that you can just go in and rewrite. No, its knowledge is this incredibly complex, tangled web, and it's all encoded across billions of parameters. If you just barge in and try to change one tiny thread, you risk ripping apart countless other connections that you didn't even know were there.
And because it's so incredibly complex, the most obvious ways to update an AI come with some truly massive, show-stopping drawbacks. You're basically left with two pretty bad options. The first one, full retraining, is like tearing down an entire skyscraper and rebuilding it from scratch just because you wanted to change a sign on the roof. It is brutally slow and ridiculously expensive. The second option, naive fine-tuning, is faster, but it is super risky. It can lead to something researchers call catastrophic forgetting, where, in teaching the AI one new thing, you accidentally make it forget 100 old things. So this whole dilemma, it's forced researchers to get really creative. And they've come up with a much more elegant, almost surgical approach. A whole new field called Knowledge Model Editing, or KME for short.
KME is pretty much the science of performing precision surgery on an AI's brain. The whole goal is to make these tiny, specific changes to add or fix a single fact quickly and, most importantly, safely, without having to go through that whole nightmare of retraining the entire model.
Now, to pull this off, KME has to follow two golden rules. The first one is called locality. Think of this as the do no harm rule. A successful edit means that if you teach the model about a new world leader, it absolutely cannot forget the capital of France or how to write a sonnet. All the unrelated knowledge has to stay perfectly intact. The second golden rule is generality. This just means the new fact has to stick no matter how you phrase the question. So if you update who the president is, the AI needs to give the right answer whether you ask, who is the president, who's the current head of government, or even tell me the name of the person leading the country. The new knowledge has to be consistent across the board. So how do researchers actually do this? How do they follow those golden rules? Well, they've come up with three main types of techniques to get the job done. You can think of them as three totally different approaches to AI brain surgery, and each one has its own set of pros and cons.
Okay, the first approach is what we can call the post-it note method. The technical term is external memorization. It's kind of like finding the right page in the AI's giant internal encyclopedia and just sticking a little post-it note on it that says, hey, by the way, here's the new fact.
And this shows you exactly how it works. Notice how the AI's core brain, its original parameters, they're never actually touched. Instead, the model just learns a new trick. Before I answer, I'm going to quickly check this separate memories folder to see if there's an update for this topic.
The huge advantage here is safety. I mean, because you're not messing with the core model, the risk of that catastrophic forgetting is basically zero. The downside? Well, all those little notes can start to pile up, which can cause storage problems, and it adds an extra step every single time the AI has to think.
All right, our second approach is the full rewrite, or global optimization. This one is way more ambitious. It's less like a post-it note and a lot more like carefully rewriting an entire entry in that encyclopedia to make the new information blend in perfectly.
So here, we are actually changing the AI's core brain. What this diagram is showing is how that new information is used to guide these tiny updates, the gradients, across the entire network. The idea is to embed the new fact deeply into that whole web of knowledge.
Now, this method is fantastic for generality. Remember that second golden rule? The knowledge becomes a real integrated part of how the AI understands the world. But it's a lot slower, it costs more in computing power, and because you're tweaking everything, there's a much higher risk you might accidentally smudge the ink on a nearby totally unrelated page.
And finally, that brings us to the most futuristic-sounding method of all, the brain surgery, or what's known as local modification. This is like performing microscopic surgery to change a single sentence on a single page of the encyclopedia, leaving absolutely everything else untouched.
This is all based on a really wild discovery. It seems that specific facts are stored in specific places inside the model, and what some researchers are calling knowledge neurons. So this whole method is about, first, finding the exact neurons that hold the old, wrong fact, and then editing only those tiny parameters.
And this right here perfectly captures both the incredible promise and the massive challenge of this approach. When it works, it is unbelievably fast and efficient. It's the perfect edit. But its success depends entirely on being able to find those exact knowledge neurons, and that, my friends, is an incredibly difficult job.
Okay, so after all that technical stuff, why should you actually care about any of this? Why does editing an AI's brain really matter in the real world?
Well, being able to edit AI knowledge quickly and safely is absolutely fundamental to building AI systems that we can actually trust. It means our fact-checking tools can keep up with the news cycle, it means our AI assistants can give us reliable, up-to-the-minute information, and it even opens the door to systems that could help fight misinformation in real time as the world keeps changing.
This technology is moving so incredibly fast, and it's opening up a future where AI is way more adaptable and correctable. But it also leaves us with one last, pretty provocative thought. Today, we're just talking about editing facts, but if we can get this precise, what's the next frontier? Can we edit not just what an AI knows, but what it believes?